July 10th, 1962, Telstar, an historic satellite communications experiment, is in final countdown. John Pierce, a research scientist and administrator at AT&T Bell Laboratories, first began considering communication satellites in 1954.
When I look back over my notebooks in late 1954, I find out that I was making entries about satellites on August 9th. And then I was calculating how much power would be reflected from a metallized balloon. And I continued to think about satellite communication off and on, but for a while, in no very pressing manner, because no satellites had yet been launched. It was only when the Russian satellite Sputnik went up late in 1957, and the first American satellite early the next year, that I began to stir around and push for the launching of an American communication satellite.
The large metallized balloon Pierce had speculated on in 1954 was a reality by 1958, created by NASA for atmospheric studies. Pierce persuaded the Air Force to use the orbiting balloon to reflect signals between the east and west coasts. The East Coast terminal housed a large horn antenna and a sensitive receiver, later used in the Nobel Prize-winning Big Bang experiments. The terminal was built at Bell Laboratories in Holmdel, New Jersey. On the West Coast, under the auspices of the California Institute of Technology, signals would be sent and received from Goldstone, California. The name of the effort, Project Echo.
Hello, Goldstone. This is Holmdel calling. Calling Goldstone.
How do you read me?
You can start the tape if you want.
Bill, start your modulation tape.
This is President Eisenhower speaking. It is a great personal satisfaction to participate in this first experiment in communications involving the use of the satellite balloon known as ECHO.
Project ECHO proved a number of things. It convinced people that this wasn't a wild dream. And the next reasonable stage seemed to be to launch an active satellite.
An active satellite receives, amplifies, and rebroadcasts communication signals. By 1960, AT&T had started a large active satellite project under the direction of E.F. O'Neill. The name of the satellite was Telstar.
This is one of 6 original Telstar satellites. Groups from all over AT&T worked around the clock to get ready for a launch date that was finally set for July 10th, 1962. And crucial to the success of the work was a host of inventions from Bell Labs: the transistor, the solar cell, traveling wave vacuum tubes, low noise maser receivers, large antennas, and missile guidance systems. The satellite was built with discrete components. It was at the leading edge of technology, but in those days there were no microchips, much less large-scale integrated circuits. The satellite was built out of over 6,000 discrete components that had to be assembled one at a time.
As the launch date neared, final preparations were completed. Tests were conducted, all systems were checked. Telstar was ready for launch.
Telstar was launched in the early hours of the morning, but it didn't reach a position in its orbit that was usable till well on into the evening, perhaps 6 or 7 o'clock. The technical people would have liked the quiet time to test the satellite by itself, But a large group of people, government officials and other eminent people, had been assembled in an auditorium in Washington, and we were hooked into the national television networks. So when we pushed the red button, we were doing it in front of the world.
Good evening, Mr. Vice President. This is Fred Capel calling from the Earth Station at Andover, Maine. The call is being relayed through our Telstar satellite, as I am sure you know. How do you hear me?
You're coming through nicely, Mr. Capel.
Telstar worked just admirably and transmitted signals in the very first pass over the Earth. The first transoceanic transmission of television by Telstar was an entirely new thing. You saw things in distant parts of the world for the very first time in real time.
I understand that part of today's press conference is being relayed by the Telstar communications satellite to viewers across the Atlantic, and this is another indication of the extraordinary world in which we live. So we're glad to participate in this operation developed by private industry, launched by government in admirable cooperation.
Satellites made it possible to communicate to very remote areas where you couldn't afford to lay a cable or even to put in extensive land networks. But above all, it caught the imagination of people. And here was something about space that was clearly of actual day-to-day use and benefit to ordinary people everywhere.
And it was only the beginning. Since the launching of Telstar, communication has become possible in ways and places never before imagined. For transmitting data, printing magazines, bringing more events home in real time, making television and telecommunications possible in remote areas of the world. Letting us witness the making of champions. And the making of history. The satellite. It started as a theoretical possibility. It has become an everyday part of our lives.